Welcome everyone. I'm really excited to be here and great to see you all. How's your journey to VMworld so far? Are you guys enjoying it? Cool, awesome. So today we're going to talk about NSX and small data centers for small and medium businesses, SMBs. So we have a great session for you, but before we begin, let me introduce myself. My name is Shahzad Ali. I am part of the NSBU Solutions Architect team in Customer Success Organization. So I work in the BU business unit, and my role and responsibility is to make sure that you as a customer are successful throughout your journey in implementing and designing NSX or SDDC solutions. And I have Dylan with me, who's co-presenting today.
Yep. Hey everyone, my name is Dylan Doxey. I'm part of the same team as Shahzad, and I wanted to reiterate what he said. We're very excited to be here talking with you guys today. We will be taking questions. We're going to try and leave some time at the end, about 10 minutes for Q&A. So if you can hold your questions during the presentation, we'll try and get to them afterwards, and me and Shahzad can hang out afterwards as well if there's anything else.
Definitely. Okay, so let's begin. So this is the disclaimer to attend this session. Now let's talk about building houses. How you are going to build a house, how the architecture of a house looks like, right? So in a typical house, you have different rooms. You have a living room, you have a kitchen, you have a bedroom. And these houses or these rooms are basically built for specific functions. So in your living room or in your media room, you want to watch your favorite game or movie, whatever, right? You want to make sure that it is built in a certain way. Maybe you want to have soundproof walls, whatnot, right? So similarly, when you are designing or creating a vSphere cluster, you basically want to create multiple clusters based on the functions that they perform. So you have the management cluster, edge cluster, and then compute cluster. In the management, you would typically have vCenter virtual machines or NSX virtual machines. And then in the edge, this is where it's talking to your physical infrastructure. So you want to make sure that the resources or the ESXi hosts you are putting in ESXi, they have certain requirement. Maybe you want greater throughput there, so you want to install better NICs over there, right? So based on the functions they perform, you want to create different clusters. But what about you are really pressed in terms of the footprint that you have? So you have a very small area where you want to build your house, maybe in the Bay Area. It's very expensive, right? So now you have this space where you want to put everything. You have the kitchen, you have the living room, you have the bedroom, everything is in there. So now it's very important that when you are building such a house, your resources are being maintained properly, and they are being allocated to the functions properly, right? So this is the same concept, exactly same concept, that when you have a small data center, you don't have a luxury to install so many number of ESXi hosts. So you are actually creating just one single collapsed cluster, and you're putting all your ESXi hosts in the same cluster. And you need to basically design it, architect it properly, and make sure that the virtual machines or the applications that you're running over there, they're getting the proper resources, right? So that is fundamentally the idea. So with that, let me tell you what we are trying to cover here in this session. So we will show you some deployment models. Now, NSX being a software product is extremely flexible, right? So you can create different deployment models based on your needs and requirements. But what we have seen that customers are using NSX in small data centers with specific deployment options. And that is what we are going to cover here, the most important deployment options that we see out there. And then we'll look at some design and deployment considerations. Okay, I have this deployment model. How can I design it to make sure my applications are okay, my infrastructure VMs are running properly, everything is getting the proper resources and attention. And then once you have this setup done, obviously you need to grow it beyond what you have in terms of maybe compute resources, maybe you want to add more features. So what are the options, and then the most important considerations over there. And towards the end, we have some case studies. So we work with customers every day. So we see these deployments every day. So there are some important use cases and gotchas out there that you should be aware of. So the main idea, the core message that I'm trying to deliver here is that although NSX is, you're deploying NSX in a small data center, that does not mean you will not get all the features and functionalities that those big guys are enjoying, right? So the big guys or the large data centers, the feature set that they have with NSX is the exact same feature set that you can get or you will get with small data centers. NSX in a small data center does not mean that you are a small customer. I have so many large customers who actually start their journey with a small footprint, and then they grow. And then I have some customers who would deploy NSX in a small data center with a small footprint based on the functions that they perform, right? So let's say if you have a DMZ or a VDI, you might want to carve out some ESXi hosts for those type of resources. So although your organization is large, but you are just putting this NSX in a small footprint in a small data center, right? And then finally, the sky is the limit. NSX is extremely flexible, powerful, so many great features out there. You can grow anywhere you want. So you can start anywhere and you can grow anywhere. Okay, so let me ask you guys, how many of you have actually deployed NSX? Wow, very good number of people. And how many of you already know what NSX is, NSX architecture, basics of NSX? Almost everyone. So that makes my life a lot easier, right? So what we have done with this technology, that if you look at a physical box, in a physical router or a switch, you will have the management, you have the control plane, and you have the data plane. We are actually decoupling it with NSX. So we have the management plane, which is provided through our NSX manager and vCenter. In the control plane, we have NSX controllers. Those are the controllers providing the logical switching or routing. They are pushing the information to the ESXi host. And then we have the DLR control VM, distributed logical router control VM, which is basically pairing up with your physical routers or controllers or ESGs to receive the routes, the dynamic routes, the OSPF and BGPs. Then the data plane that you see there is powered through the ESXi host. So that's the distributed model that we have out there. So these functions that you see, the firewall, the distributed firewall, the distributed logical router, logical switches, they all are distributed across a number of ESXi hosts. So that's your data plane. And then we have another component in the bottom for the data plane purposes, which is powered through the virtual machine. We call it ESG, Edge Services Gateway. That is our virtual machine, like a Swiss Army knife, I call it, which is providing you the load balancer, the firewall, the routing and switching and NAT and whatnot, right? So that's very high level is the architecture or the components. Okay, so let's take a look at the large data center, how a large data center is being built today, right? So if you look at this diagram, you will see different clusters, vSphere clusters. So you have the management cluster. This is where you have your vCenter and NSX manager. Then you have your edge cluster. So you're deploying edge services gateways over there in the edge cluster. And then you have your compute cluster, right? So there are separate clusters in a large data center because you have so many number of hosts. And typically in large data center, what I have seen that you would have somewhere between greater than 100 ESXi hosts, thousands of virtual machines, and your bandwidth requirements are more than 10 gig. So definitely you need to design it accordingly based on the requirements that you have. Then what about if you are a medium-sized customer, you don't have that many number of ESXi hosts. So what we do, we allow you to collapse your management and edge together in one cluster. So that is what you see on this diagram, right? So your vSphere, vCenter, NSX manager, NSX controllers, they are in one cluster, and then you have the payload cluster based on the virtual machines you're running over there. Could be database, virtual machine, web servers, whatnot, right? So that is a reference architecture for a large and medium-sized data centers. But obviously, if you're running it in a small footprint, you don't have that many number of ESXi hosts, then you are basically putting everything together in one cluster. So your vCenter, your NSX manager, everything is in one single cluster. Now, you know that when you are putting everything in one basket, you need to make sure that these virtual machines, your infra virtual machines, your workload virtual machines, they're getting the proper resources and whatnot, and that is exactly what we have, we are going to cover. So resource reservation in essence becomes really important for a small data center. Okay? So far so good? Okay. Now let's take a look at the deployment models. What are the most common and most widely deployed deployment model out there with NSX? So the number one deployment model is the security-focused deployment model, right? So this is where majority of our customers are starting their NSX journey. Why? Because this is a non-disruptive model. You don't need to make any changes on your physical infrastructure. All you need is just one single virtual machine, which is NSX Manager. And you can actually deploy NSX Manager and implement security-focused deployment model on your existing vSphere installation with VLAN backed port group, the regular port groups that you have. That is why it is extremely popular. There is no need to make MTU changes or no need to configure VXLAN or anything like that. Then we have something called the centralized edge deployment model. So this deployment model is actually powered through our ESG virtual machine. Right? So you have one NSX Manager and one ESG VM, like any regular VM that you drop into your vSphere infrastructure, and you can now enable a lot of use cases. So you can have the edge load balancer, you can have edge firewall, you can use this edge as a routing device between your virtual and physical infrastructure. Right? So that is what our customers are using when they are not allowed to make changes on their physical infrastructure, if they are not capable of making the MTU changes. So they will use this model as a transition step before moving towards the full stack model. Okay? So the full stack model is the model where you get everything. You're getting the full benefits of NSX. So you're getting the logical routing, you're getting logical switching, VXLAN, you're getting distributed firewall. You are enabling all the use cases that are possible with NSX with this full stack model. But yes, it does require you to make some changes in your physical infrastructure. So you need to make sure that you have at least 1600 MTU set up on your physical infrastructure for your VTAP to VTAP or for your VXLAN communication. Only one VLAN, not everything, but just at least one VLAN. That is important, right? So that will enable the full stack model for you. Okay, so that is a high-level picture of all the models together. Now let's dive into each one of these models. Okay, so now first we will take a look at the security-focused deployment model. So security-focused deployment model is where, let's say, you already have a vSphere deployment. Your boss or your manager comes in and says, you know what, I need to enable PCI. My PCI compliance is coming. I need to comply these virtual machines for PCI. How can I quickly do that? This is the model you will pick. You will say, okay, I'll just do it in a week or maybe 2 weeks. Just drop one virtual machine, create security groups, and then enable PCI compliance for them. That is the model you will use. Within this model, we have two important use cases. One is the distributed firewall use case. So you can use security-focused deployment model just for the firewalling purposes, for east-west firewall, right? That's one use case. And the second use case is the agentless antivirus use case. Agentless antivirus means that your virtual machines are not running any agent inside. The antivirus is being pushed to ESXi host. Your ESXi host is responsible for scanning those virtual machines for antivirus or anti-malware protection. You have seen so many attacks recently, like the WannaCry attack, the T attack, so many other attacks. And this is the technology that you can use even today, right now, and then you can just protect your workload. That is why it is so important and powerful. And it's so easy to deploy. So what are the requirements when it comes to deploying a security-focused model with distributed firewall use case? So minimum, we need 2 ESXi hosts. That is the minimum requirement, but in production, my recommendation would be to at least go with 3 so that you have some buffer. In case one host is down, you have another extra one to take care of the workload and the infra VMs, right? So, and then in terms of the footprint, virtual machine footprint, you need only 2 virtual machines, that's it. And you look at the CPU and memory requirements, they are not that much. You can in fact deploy this solution with tiny vCenter appliance with embedded PSC, Platform Services Controller, so easily. That's all you need. And you're running everything in one single cluster, right? So that's how the use case can be deployed or enabled in your data center. And then we have the security-focused deployment model with agentless antivirus use case. So now agentless antivirus is being provided through our collaboration with our security partners. like Trend Micro, Symantec, McAfee, Fortinet. These are the partners, or the list is long. I'm just giving you some few names here. So this feature or use case is provided through these partners. Now, when you're deploying agentless AV, you have to remember that you are adding additional virtual machines to your footprint. One is the GI SVM, Guest Introspection SVM, which is a very tiny VM, does not take a lot. And then a partner SVM, right? So your Symantec or Trend Micro service VM is deployed. So when you're deploying it in a single cluster, now you have to remember that this is a cluster level operation. So when you enable agentless AV, all your ESXi hosts will get these service VMs, 2 service VM per ESXi host. You cannot pick and choose, right? So that is what you need to remember. And again, look at the footprint. It's not a lot, right? So the GI SVM you can see is very small. The partner SVM, I don't have the numbers because it will depend on the partner SVM recommendation or their virtual machine size. So you have to go and take a look at your partner, security partner, if you are going to deploy this model. Okay? Now let's take a look at a centralized deployment model, right? So that's the model I showed you in the big picture in the middle. So that's a centralized model enabled through one ESG virtual machine as services gateway. That's like a Swiss Army knife, enabling load balancer, NAT, routing, switching, everything through one single virtual machine. This is the model you're going to use when you are deploying, when you cannot make MTU changes, like I said before, right? So it's like a transition step before going towards full stack. Because our recommendation, or my advice is to go with full stack. Why would you just deploy Edge Services Gateway? With full stack, you'll get the benefit of everything. Because this will not provide you distributed routing. No optimized routing here, because your ESG will typically will become the default gateway. So all the traffic will be hairpinned through this ESG virtual machine. So that is the reason my recommendation is to go with the full stack model. So this is the full stack model. Right? So what you see here is a VXLAN based overlay. That's what we create in virtual space for you. So it's not dependent on any hardware. Right? So all you need is just the ESG that will pair with your physical infrastructure, with your router through OSPF or BGP, or could be static route. You will learn the route and you will just send the routes out to them. And that's how you will basically get the full stack model. So you get the distributed routing, the DLR, the logical switches, and everything with this. Yes, it needs you to make those changes, the MTU changes that is required on your physical infrastructure. Okay, so this is what we recommend for the deployment of this deployment model. So you need at least 3 ESXi hosts for this deployment model. Why? You look at the NSX controllers. We have to have 3 controllers, NSX controllers in a cluster. And we recommend you to put these controllers VM on their separate ESXi hosts. So that's what you see here, right? 3 different controllers on the ESXi host. And then you have this ESG, the Edge Services Gateway. Now this Edge Services Gateway could be deployed in ESG HA mode or ESG ECMP mode. We do support that. But in this model, I'm just showing the ESG in HA mode. Right? And then look at the footprint again. So you have the vCenter appliance with embedded PSC. You can use the tiny one. NSX manager, 3 controllers, and 2 ESG virtual machines. I'm not showing you the DLR control VM here because I'm assuming that this customer is using static routing. So when you're using static routing, you do not need to deploy DLR control VMs. So you can actually save 2 virtual machines there if you're really pressed. Okay. All right, so now let's take a look at the vSphere considerations. So basically vSphere, NSX for vSphere is running on your vSphere infrastructure. So we want to make sure that your vSphere deployments are robust. You deploy them or implement them based on the best practices that we have. But I'm going to touch upon 2 important virtual machines here. One is the vCenter. Right? So the vCenter virtual machine, when you're deploying vCenter, you can deploy vCenter using 2 options. One is that you deploy VM and then you enable PSC service inside the same virtual machines. So like embedded PSC options. So that's the option you see here, option number 1, right? And then the option number 2 is that you deploy vCenter in a separate VM and then PSC in another VM. So now in a small data center, embedded PSC will work fine if you do not have any plans to grow in future. But if you are thinking about growing your deployment, then my recommendation would be to go with this option number 2, where you have a separate virtual machine for your PSC. Because that will also allow you, if you are, for example, going to enable a cross VC use case. And by the way, this is very important use case even for small customers, the cross VC, multiple data centers for DR purposes. And we have a case study at the end, which Dylan is going to present. So for that reason, my recommendation is that if you're planning to grow, if you're going to enable more vCenters, or if you have a DR that you need to take care of, then go with option number 2. Okay? Okay, so what about the virtual machine form factors? So virtual machine form factors are, this vCenter comes into different form factors. So you have the tiny, small, and medium. And based on their form factors, we allow you to have or support number of hosts and virtual machines. For example, tiny will give you 10 hosts. So you can have 10 hosts in your deployment. Tiny with embedded PSC is good enough for NSX deployment. But again, our recommendation is, or my recommendation is to go with a small, at least a small, so that it will give you some headroom. If you want to grow in future, at least you have options to grow all the way to 100 hosts and 1,000 virtual machines. In terms of footprint, you can see it's not that much. So even if you go with the small, you need 4 vCPUs and 16 gig of memory. Okay. Licensing. So licensing is something very important for small customers. Why? Because when you purchase NSX license, basically that enables you to deploy any service you want. Because if you look at a traditional physical infrastructure, if you're deploying a load balancer, you need a separate license, right? And then if you're deploying a router, then you need another license. And then in terms of operating it or the support calls, you need to make multiple calls to make sure all these companies or vendors are talking to each other and solving your problem. With NSX, you're getting everything in software under one licensing scheme. And with the vSphere, if you look at vSphere, we have a number of different options. I'm just showing you an important one here. So you have Essential Plus, Standard, and Enterprise Plus here. So NSX is supported on any vSphere licensing scheme. That's important. Okay? And number 2 is when you are deploying NSX, one of the requirements is to have VDS, because NSX is only supported on vSphere VDS switch. No other switch but VDS. And VDS comes with Enterprise Plus license. But if you have an NSX license, the VDS is already part of it. So you don't need to purchase Enterprise Plus. Right? So if you even have Essential Plus vSphere license, and if you have NSX, you are getting VDS for free basically. Right? And for the NSX, you can look at the different licensing scheme. This is just a reference slide for you. So basically we have a standard, advanced, and enterprise licenses. So in the enterprise, you can see we have basically routing and switching. In the advanced is microsegmentation and security, and then enterprise will give you cross VC. So the list is long. This is just a snippet of it. So I would encourage you guys to go take a look at the URL I have in the bottom. So that is what I have planned to present to you guys. I will hand it over to Dylan. Dylan, you can take it over.
Awesome. Thank you, Shad. Hey everyone, so now we're going to talk about NSX component considerations. And one thing to note about NSX is that it's very modular and flexible to install, okay? But Shahzad touched on this a little bit earlier in the presentation, and I want to harp on it, and I'm going to mention this several times and throughout the next few slides. But really, when we look at NSX in small data centers, we're trying to make the most out of the reservations or the resources that we have in a limited number of hosts. And it's important to understand what reservations are at a vSphere level. So reservations are memory or CPU that is specifically set aside for particular virtual machines. And it actually removes those resources from the aggregate pool that your other virtual machines can draw from. So what this means, when we're looking at this slide here, our NSX manager has 16 gigs of memory reserved by default. That means that we're literally going to take 16 gigs of memory from that host, and we're not going to let any other virtual machines use it. That is dedicated to that NSX manager. It's reserved, right? So it's important that we understand how many resources we have in a cluster and how much we're guaranteeing to our virtual machines. vCPU and memory modifications are allowed with the NSX manager, but please stick to the default. If you find that you're running into, high CPU usage, high memory utilization, something like that, there's a lot of different things that we can look at to try and alleviate that pain before we start to throw more resources at the virtual machine. Since we're talking about trying to make the most out of what we have, we definitely don't want to just keep throwing resources until it works. It's also incredibly important to add the virtual machine or the virtual center virtual machine to the NSX VM exclusion list. This removes it from being a part of the distributed firewall. The reason that we want to do that, you can actually lock yourself out. All firewall rules are done through the vSphere web client, and if you set the default rule to block without allowing vCenter the proper access, you can't get into the web client to change the rules to get back into the web client. It's a call to GSS. The NSX Manager backup is also an incredibly important part of the NSX Manager. We do that through FTP or SFTP. One other note I will make about this, there is a password that you get to set for that backup file. We do not have a backdoor to get that. Okay, so when you set that password, make sure it is well known, make sure it is, in some sort of key safe or something, because when you go to restore, if you do not have that password, we can't help you. We have no way to get in. The NSX Manager is not sitting in the data path of virtual machines, right? We saw that it was just in the management path, so this is where you're going to be setting up all of your different firewall rules, setting up different types of routes, logical switches, that sort of thing. And when we talk about virtual machine boot order, we want our NSX Manager to come second, right? We need our virtual center server, our PSC, domain controllers, things like that up and running first, but the next thing should be your NSX Manager. Along that same vein, we have our NSX controllers. This is only for the full stack option that we talked about before, where you're using that logical distributed routing or that logical switching. Okay? The NSX controllers are virtual machines. They come in a set of 3. Okay? And we want to create manual anti-affinity rules to make sure that these virtual machines run on separate ESXi hosts. An important thing to note is that we have this should line here. So DRS and HA are actually smart enough to work together to say, just so long as I have 3 active hosts running, I'm going to put these 3 different controllers on different hosts. If I lose a host and I go down to 2, well, we still want all 3 of our controllers running, so we're going to restart it on one of our active hosts. That's what the should means. As soon as we get a 3rd ESXi host up and running, we'll go back to that method where we have controllers on different ESXi hosts. Our controllers come with 4 gigs of memory reserved by default. Do not modify the resources on these virtual machines. They are also not in the data path, so our NSX controllers learn, right? They're what's holding on to information like where do your virtual machines live in your environment, which hosts are part of which logical switches. Okay? And our NSX controllers need to be 3rd in our VM boot order. They are going to come up after our NSX Manager. Next, we're going to talk about our DLR control VM. So we touched on this a little bit. Shahzad actually put it in his slide that this is not a required virtual machine, even if you are using our distributed logical routing. The only time we need this virtual machine is if we are using dynamic routing, specifically OSPF or BGP. We recommend that the DLR control VM be deployed in NSX HA mode, which, if you're not familiar, NSX HA mode basically just has an active and a standby virtual machine, and they communicate in heartbeat with each other. As soon as we stop receiving heartbeats from the active after X number of seconds, the minimum being 6, we will kick over to the standby. The standby declares itself as active and takes over everything. vCPU and memory modification is disabled. Again, don't change this here. This virtual machine is very, very small. It only has one vCPU and 512 megs of RAM. It does not sit in the data path. Okay, it is only there to learn those routes, and any anti-affinity rules are going to be automatically created when you enable HA. Our Edge Services Gateway, that Swiss Army knife of a router, load balancer, firewall, all that kind of good stuff, comes in a few different sizes of form factors. We recommend to deploy as a large ESG as a default. Okay, the large ESG comes with 2 vCPUs and a gig of RAM. It's only got a 1 gig storage device on it, and all of the reservations here are enabled by default, and the virtual machine is locked down. Keep in mind, your ESGs can be upgraded at any time. It's simply just a redeploy operation. So if you start off with large and you find out, hey, that's not going to work for us, it's just a couple clicks of a button, and you're back up and running to an extra large. So how do we know which ESG that we want to go with? I said that the large is kind of the default, but there's also different ways that we can set up our Edge Service Gateways, okay? One of those is in NSX HA mode, which we had just discussed, the active standby heart beating. The other is called ECMP, Equal Cost Multipathing, okay? With ECMP, we take several different edges, okay, at least 2, but up to 8, and we present them kind of as one logical aggregate route. So your DLR control VM will actually have several routes to these different ESGs to get out into the environment. So we ask the question, do you need stateful services in your environment? If the answer is yes, we have to then decide what is our throughput requirement. If we need more than 10 gig, then we have to go to a multi-tier design, which we're not going to really dive into in this presentation because that's pretty uncommon for a small to medium DC. If you're looking at less than 10 gig, we go with our ESG HA mode. If we do not need stateful services, then we go directly to our throughput requirement, okay? If we need less than 10 gig, again, ESG and HA mode is kind of the easy way to go. If you do need more than 10 gig, then we want to look at an ESG and ECMP. So ESG with HA, all of our anti-affinity rules to keep those active and standby virtual machines on different hosts are going to be created automatically. And a note that we have on here, we want to absolutely make sure that we create DRS anti-affinity rules for our active ESG and our active DLR control VM. Okay, we do not want those on the same host. If they end up on the same host and that host ends up having a failure, we will actually start to drop traffic. ESG with ECMP, we'll need to manually create those anti-affinity rules, okay, and keep all of those ESGs running on different hosts for the same reason. If you lose one host, you don't want all of your networking equipment to go down with it. And again, you want to avoid any active ESGs and active DLR control VMs on the same host. So you can see the diagram that we have in the lower right-hand corner here. We have our ESGs sitting on host 1 and host 2. So we can lose either of those hosts, and we will still have active ESGs running. On host 3 and host 4, we have our active DLR control VM and our standby DLR control VM. So vSphere High Ability and NSX. vSphere HA is incredibly important when we start to talk about small data centers, and more specifically, we want to look at emission control. So admission control is what vSphere uses, vSphere HA uses to let you know when you're running out of resources, okay? We want to be able to guarantee that in the event of a failure, we can restart all of the virtual machines that you have running. So we have a couple of different ways that we can set this up. The first is called the slot policy, and we can configure this in N+1, N+2, or however much you want, or however many hosts you want for redundancy. With the slot policy, you'll actually go ahead and manually edit, or you can go with the default of slots, which are basically buckets of CPU and memory. And we allocate those slots, or we do calculations based on those slots of how many virtual machines you can have running on a host at any given time to still satisfy a failover. This is an example of what the slot policy looks like in the event of a failure. we'll actually just migrate those virtual machines, re-register them on new hosts, and restart them. Cluster resource percentage lets us get a little bit more creative, and in a small DC, when we don't have a lot of resources, that's very beneficial. So cluster resource percentage actually allows you to set a percentage of resources across all of your hosts in the cluster of how much you want to reserve for failover capacity. Now, what this really buys you is the ability to run non-essential workloads and set them to not be restarted in the event of a failure. So you get more out of your environment at the cost of not being able to restart those virtual machines in the event of a failure. And finally, we have the dedicated failover standby host. How many folks are running environments with less than 10 hosts here? Just a quick show of hands. Don't run that. It's meant for very, very large environments, but it actually makes sure that no virtual machines are running on an active host. And again, we're trying to get the most bang for our buck. So we really don't want this to be our setup. We want to be using all 3 of our hosts in this example at all times. The HA restart priority is how we use that cluster-based or the percentage-based HA admission control in order to guarantee that our NSX resources are started first and have the highest priority, and things like dev workloads or non-essential workloads can be set as, don't restart or secondary virtual machines here. So we'll give you kind of an example. This is in a lab environment, so my host had only 10 gigs of memory on it and very, very little vCPU. But when you're going through and making these calculations, you need to know what you have to work with. So total up your cluster resources, make notes of how much CPU and memory are available. And I've got those listed up here as our total cluster CPU and total cluster memory. So the 2 options that we really have for HA, again, are that slot-based HA policy and our cluster-based. With the slot-based, you can go in and you can go with the cover all powered on virtual machines policy. I do not recommend that. If you have a virtual machine, a large database, or something like that, it will skew the slot size, and it will make it so that you don't get as many virtual machines running as you could. So this fixed slot size allows you to go in and actually say how much CPU and memory do we want to allocate to a slot, and how many slots will a particular virtual machine take up. Again, that cluster-based policy really just says reserve 25% of our memory, 25% of our vCPU, and then we're leveraging those VM restart priorities in order to ensure that NSX, critical components, your DC, DNS, AD, of course, is being restarted and your dev workloads are not. vSphere resource pools. So before I came to work for NSX, I worked in our GSS department. Specifically, I worked in sysops for quite a time. And resource pools were one of those things every time I saw them and a customer called up and said, hey, my VMs are running slow, this was the first culprit, and this is where I looked. So use resource pools. They are good if they're used properly. And you can use these resource pools to guarantee CPU and memory to priority workloads. So with NSX, we provide reservations for our virtual machines by default, right? We give it most of what it needs. But inside of your environment, you can still carve out these resource pools and allocate CPU and memory shares to them to ensure that your NSX workloads or your high priority workloads are receiving those resources while you can kind of throttle back some of those less important ones. You want to be very sure of what you're doing when you're looking through resource pools. You can choke your virtual machines. Okay. One of the settings on here, I know it might be a little bit hard to see, is the reservation type set to expandable. This makes sure that if there are more resources kind of at that top level where the ESXi hosts are, that we can give it to those virtual machines underneath. And we want to make sure that we're using cluster calculations and VM requirements to build all of these pools properly. Also make sure that you're planning for growth. I can't tell you the number of times that I've had that call where the resource pools were even set up correctly, and then they were forgotten about. 6 months later, we've grown 20 virtual machines, and now all of a sudden that resource pool isn't doing what it was supposed to do, right? We're 20 virtual machines over where we were supposed to be. So for our VDS, VDS requires vSphere Enterprise Plus, but of course if you've purchased any licensing of NSX, this comes with it included. We get the question all the time when we go to customer sites, how many VDSs should I use? And the answer for the small data centers, keep it simple, just use one. The benefit of splitting out that VDS requires the additional virtual networking adapters or the physical networking adapters to set up that VDS to be used. So in a small DC, we probably don't have many NICs to play around with here, and it doesn't hurt anything running your NSX workloads, your logical switches, along the same VDS that you're running your compute workloads or your management. Our recommended teaming policy for your VTEPs, if you decide to use logical switching in VXLAN, is route based on originating port or source ID. This allows us to do multi-VTEP if needed without having to set up LACP or static ether channel or anything like that. It is the most simplistic way to go about it, but it works very, very well. Another thing to note, as Shahzad had mentioned, the MTU, when we are using logical switching, does need to be set to a minimum of 1600. So, growing NSX small DC deployments, nearly every customer I go to, regardless of if it's a small mom and pop shop or a Fortune 500, is going to start off kind of small with their NSX environment, and then they're going to plan on growing. And when you grow NSX, you need to make sure that you know what the compute capacity is going to be. We need to understand the throughput requirements, what features and services are going to be used in the future, as well as how we're going to migrate there and if we're expanding out to multiple sites. So we're going to jump into a few case studies. The first one here is the kind of the standard, starting off with our DFW and then moving into the full stack. So you can see here, we start off with virtual machines just running on a normal VDS, and we get our distributed firewall set up. We get our microsegmentation going. From there, we can expand out into the agentless AV. Okay, or really any of those network introspection services or guest introspection services, excuse me. From there, we grow our VDS and add a DLR to it. We create our logical switches and set up our NSX edge gateways. And now you're looking at the full stack deployment. This is a phased approach, and this is the way that the big guys do it. Okay, start off with the use case that's most applicable to you as a customer and continue to grow up from there. And really that DFW use case, the microsegmentation, is what we probably see the most. Another case study is going from a single site to a multi-site. And when you're planning for that small DC deployment, this is another one to keep in mind. As Shahzad had said, a lot of the smaller data centers will actually use cross VC for disaster recovery. It's a fantastic use case. But when we're setting it up in our single site, we want to make sure that we're actually setting everything up with universal objects. This is because when you expand into the secondary site, you don't want to have to recreate and redo all of that work that you've created on local objects and move them over to universal. Once that's configured, we have our universal DLR, we have our universal logical switches, and our universal firewalling. Okay? We can have it across to both sites.
So one question I have for you guys. Can you guys hear me okay? Okay, so are you guys using any DR today with SRM, vSphere SRM? Just want to see show of hands. So what is your DR story? That's what I would like to know after we are done with the session. I would like to know what you guys are planning to. Are you guys planning to use cross VC, NSX cross VC?
I think we got a few folks in the audience that are using it. Yep. So the key takeaways from the session that we have here, all data centers are created equal as far as NSX is concerned. When you buy the licensing, you get all of the bells and whistles that the big guys get, and we want you to leverage them, okay? They're just as important in a small DC as they are in a large environment. And a small DC doesn't mean a small customer. Again, the big guys all start off in a relatively small environment. They may have a vCenter that's created for a specific workload or a specific organization within their entire company, and then they continue to grow out, right? They kind of use that to test the waters a little bit. And you can start anywhere and you can grow anywhere. That's the beauty of NSX.
Yeah.
It's modular, it's flexible. When you're looking to those secondary sites, when you're looking to those third sites, we can tie in.
So, do you guys have any other questions? Any question on this slide or the previous slides that we mentioned? Because we have time left here. Can you come to the mic, please, and then yes. So we allocated some time for you guys for QA, like I said.
You talked about if you're doing a single site with an expectation you'll grow to a second site at some point in the future, doing the initial deployment using universal objects.
Yes.
Cross VC requires the top level NSX licensing. If I'm running single NSX right now, and I know I'll likely go to a second site in the future, but only one site right now, do I need that top tier licensing to do universals, or can I do universals single site without that top tier licensing?
That's a fantastic question. You do need the top tier, you do need the enterprise in order to create those universal objects.
Okay, let's move on, I guess. Yeah.
Sure. So folks, we're kind of wrapping up here a little bit. When it comes down to getting started with NSX, we have a number of resources for you guys to go through. Please make sure that you check out the HOLs while you're here. If you don't have time, it's okay. Those are going to be listed after the conference, after VMworld. They will be available online all year long. So make sure that you're getting the most out of your time here, and kind of going to things that you maybe are not going to be able to do later on. We have a ton of NSX sessions, the Meet the Experts bar, as well as training and certifications. And one final thing, please take time to fill out your survey. Let us know what we did well, let us know what we didn't do well. I mean, unless of course you're going to give us a bad review and then maybe forget about it. You know, it's.
So we have some time left. Yes, I see you have a question again.
I'm sorry.
Yes.
The gentleman in the red shirt that asked the question before. Come over here.
Yeah, so we have some swag here to give away.
Yep, if anyone actually, oh goodness.
So if all the questions will get something.
Yes, our wonderful Maureen, our project manager on my team, has brought Run NSX cookies. So if anyone would like one, please come on up and grab one. They are free. I promise I won't charge you.
Yeah, it's like the VDS, which is free.
I have several questions, actually. One, yesterday I had someone mention that they had their management cluster in a VXLAN within NSX. Is there any way of making this work with a collapsed cluster?
Yes.
Because I've had problems with it previously where we have domain controllers that are not up yet because the vCenter cluster is not up yet, and I can't get the vCenter cluster up without the domain controllers up, and I can't get that up without NSX. It becomes like kind of a catch-22.
I'm sorry, I missed the first part of it. So you're running your infrastructure components on?
It's a collapsed cluster, so it's all part of one cluster.
Okay.
And we've had problems, or in the beginning we had problems where we had domain controllers that were sitting or living within NSX, within a VXLAN. And when they were down and needed to come back up, vCenter wasn't able to come up because it couldn't talk to the domain controllers. Mm-hmm. And it became this kind of catch-22, and we ended up having to move the domain controllers back out of the VXLAN space and down to a normal VLAN to get the environment back up.
And that is the correct way to do it. So a lot of those management components, if you have those dependencies where they need to be up before the NSX components are, they're going to have to be run on a VLAN backport group.
Okay, thank you. Two, you mentioned obviously having the vCenter server on the exclusion list within NSX Manager. Mm-hmm. Does the external platform services controller need the same?
It doesn't, because you can still get into the web client, or you should be able to.
Okay, unless you're locked out of your root account.
Yes.
That's where I am right now. And then that third one, sorry.
You can come back.
Okay, I forgot about it.
Yeah,
so.
no worry. The QoS is quality of service is taking precedence. Okay.
Yeah, have you considered a new licensing model for that first use case of just microsegmentation?
Yes. So for microsegmentation use case, you need the NSX standard license, the one in the middle.
The advanced one?
The advanced one, sorry. Yeah.
Have you considered a lower level that doesn't include things like VXLAN and some of those other components that you don't need in that use case?
So that is the licensing scheme created by our marketing team. So that's what you get when you purchase the license.
You got the nerds up here, man.
Yeah.
We don't make those rules.
We don't.
One word answer, no. So I work on a team, we have a setup that's, I assume pretty typical. We have pretty much a main data center. That's where vCenter resides. And I'm on a team that deals with basically all the remote sites, and then data center team controls vCenter. We're looking at NSX. NSX, probably the distributed firewall would be our first use case out at the remote sites. Our issue is how much, if we don't control vCenter, what are our options for deployments if we can't really get the buy-in of the data center team, if they're still like, we're not interested in NSX, but we want to use it out in the field? What are my options?
So when you say that you don't really have control over vCenter, do you have access to the web client?
Yeah, I have access to it, but yes, I have the administrative ability to go do stuff. It's just like, am I going to get my fingers cut off politically after doing it?
You might, yeah. It's always kind of a challenge when we walk into those type of political landscapes of getting folks kind of bought into, the entire vision. It's a very new software, right? And a lot of folks went through this with virtualization when it first came back out with, ESX 3.0 and so on. So you can still administer the environment. There are different levels within the web client of different permissions and that sort. But yeah, if you don't have access to it, it's going to be a collaborative effort between you and that team to make sure that it works.
So, but all the components like the NSX manager, for example, if I'm first deploying this out at a remote site, does that NSX manager need to be in the data center where vCenter is, or does it need to be out at the remote site?
You need it in the data center where the vCenter is going to be.
Okay.
Yep.
Thanks.
Okay. Thank you.
So we're in a situation where we have 2 data centers, and we're looking at getting NSX in just one to start off with.
Okay.
Setting up microsegmentation, getting that whole set up, and then hopefully expanding to the other one in the future. We have SRM set up between these 2 sites in a DR scenario where we have all these VMs that are set up with microsegmentation and everything. We have to fail over to the other site. How does that work? I mean, with no NSX licensing at the other site at all.
It's a very good question. As far as failing over to the other site, the virtual machines would not be protected there. So unless the other site becomes licensed and we can do a universal distributed firewall, universal logical switches, then we can manage it. But yeah, it won't adversely impact the virtual machines if all you're using is the DFW. They just won't be protected.
Okay.
Can I add to that?
Sure.
I'm also on the same team. The licensing for NSX, if it is strictly a DR scenario, covers your DR scenario. So I don't have to have a second license for my other site. I like your caveat.
I like your slide, but how can I get
Right.
Right.
Yep.
Yeah, and this
I like
would
your
be
slide.
this would be 2 active data centers that also function ER sites. So, yeah. Yeah. So we would just be yeah.
Switches really not a production workload from a VDS perspective.
So the failed over VMs just wouldn't be pretended.
Exactly. Yep. You're welcome.
So if we deploy our vCenter, our vSphere and PSC combined, is there a way to convert it to separate out the PSC from vCenter, or do we have to start over and redeploy?
Yeah, unfortunately, it's kind of a store and set it up as an external.
Okay,
Yeah.
thank you.
Yep.
Okay, I see a couple options that I might start with. So the microsegmentation and the ESG using just the VPN component of it. And so the ESG, you said, that becomes your default gateway. Is there any other options besides making the default gateway? Or can you use your existing infrastructure, physical default gateway?
So are you talking the SSL VPN or the IPsec?
Either one.
Either one. So the IPsec is going to be the site-to-site one, and that will require that to be the default gateway. For the SSL VPN, you're still going to end up using the ESG as the default gateway, but it will only be for the networks that you specify that are part of that VPN.
So you would need the DLR.
You can do that with the ESG still.
Okay.
Yep, that's only G.
And so he brought up second question, you brought up the DR only using NSX. Can that be a separate virtual center, but just using a cluster that's only DR? Or is it the whole virtual center has to be DR? Because we could, have a second, some active nodes, and then have a separate cluster that's just DR. And you can move the license. Okay, thank you.
Hello again.
Hey.
So my next question was, we have two vCenter environments that both have two separate NSX setups currently. Is there any way to kind of easily, or is there a path to merge the two to make a cross vCenter NSX environment?
There absolutely is. So it's a little bit more in depth than probably what you want from a talk here, but it's really just setting up the primary NSX manager and assigning it as the primary role, and then secondary or the secondary site being assigned as a secondary role. There is a white paper that goes through the details of how to do all of that.
Okay, so if it already exists, would it be a process of recreating it all from scratch, or is it a process of migrating the already existing NSX manager?
It'll be a process of migrating during the existing. Now, the controllers that you have set up in the secondary site are going to go away. You'll only use a universal cluster in the primary.
Okay.
And then any of those local objects, you know, if you want them to be universal, will have to obviously be recreated.
Interesting. Okay. Also, is there ever going to be a possibility of changing the routing protocol, layer 2 routing protocol on the uplink port group for the VTEPs? I had a situation where I had it on source system routing and I wanted to change it to LACP. And after much troubleshooting and much agitation, it turns out that you had to recreate the entire NSX cluster from scratch to do that.
So come see me afterwards.
Yes.
Okay. I can do that.
Hey guys. Actually, I'm Cisco networking, and I like to deploy the NSX after I saw the feature. So I'm running EIGRP protocol, but actually, after I was playing in Hans Lab yesterday, I found there is redistribute stuff between OSPF and BGP. If I'm gonna deploy NSX, it's gonna affect my network.
No.
Because I'm running EIGR.
No, it would not actually. So on the ESG side, you will run the supported routing protocol, OSPF or BGP, and then you will just redistribute it from your physical side. That's it. Simple.
Okay, so I don't need any change on my network environment.
Not a major change. You just need to make sure that you are sending the routes to us, to NSX ESG, and then we will give you the default route anyways.
Oh, okay.
Not a major change. I have seen so many customers doing it already. Not a big deal. Yes, sir.
Hello. So we're running NSX right now for agentless antivirus introspection. And with the guest introspection VMs having set, CPU and memory, we keep running really hot on memory. But every time, you're not supposed to edit them, or if you redeploy them, they're back to a low amount. And so it's just perpetual high memory, red alerts all the time on those VMs.
All the time for the guest introspection?
Yeah,
What partner are you using?
Kaspersky, Virtualization 4.0.
Okay, so this is something, we need to take a look, because I did not come across any use case or issue where you try to redeploy it and then it will eat up more resources. That's what the issue is?
Just no matter how many times you redeploy it, you immediately run into just alerts because it's running, 80, 90, 100% memory.
That is something we have to troubleshoot through GSS actually, because I have not come across it.
Okay.
Yeah, so.
Thank you.
Yep.
Or you can send me an email, I will just follow.
On a deployment on Metro Cluster, how you deploy, and you say that you have two sites, it's a Metro Cluster, it's a stretch Metro Cluster, how you deploy in a small solution for that? Because you have to have two sites, and then something happens, both need to be active.
Absolutely. So there is an option called local egress when we talk about cross vCenter, where you can actually have your gateways in respective sites have their own routes out through the infrastructure. So in the event of losing site A, it's not like you're tromboning the traffic over to a dead site. You can just egress out of site B.
Oh, okay.
Hi, I work for a reseller, and all the buzz about AWS. So, how would we, I know you didn't address it here, and I don't know if you can address it here. I know it's still in development, but what does a customer need if they're interested in having NSX on-prem and then working with AWS?
He's the AWS, by the way, so.
Oh, thanks, man. No pressure.
Yes.
Yeah, so it's on the roadmap. There isn't a ton of information that even I was given when I was on the team and helping out the VMC on AWS folks. So I know that it's something that we want to do, but I don't have any details about what that would look like today.
Okay, because I went to one of the hands-on labs and it was a NSX as a service, but that's all AWS, right? But does that speak with an NSX on-prem?
Yeah, so this solution that we are going to have this Amazon cloud solution, then you can have your on-prem data center, and then you can have your data center in the cloud, in Amazon cloud, and then you want to connect them together, right?
Right.
That's the use case. So yes, definitely that is.
And that would just be the vCenters talking to each other then?
That will be like vCenter talking to each other. That will be NSX manager, making sure that your DLR, your logical switches are talking to each other. And then you saw that, were you there in the keynote? There was a demo where they were migrating the virtual machines from on-prem to the cloud and from cloud to.
Right. Want to make sure that applied to SMBs.
Definitely. It applies to SMB because if you look at the Amazon data center architecture, you purchase 3 or 4 ESXi hosts and then you deploy everything in one single cluster.
Right.
So that's definitely relevant for SMB. Go ahead.
Absolutely, yeah.
That is something you will see in future. Yeah.
Okay, great, thank you.
Yeah, thank you. All right, everyone, thank you again so much for hanging out. Please make sure that you get a cookie.